Number 7. If you looked at number 6, this is very similar, but a little more challenging because the demand function is more challenging. So it's elasticity of demand. Again, you need to remember these formulas, write them down. In this case, x equals is p, so they use p all the way through here. The textbook, though, I looked up, it's got this formula, so that's why I've got it. I guess I should put my little x here. E of x, the elasticity is equal to this. So derivative of the demand function over the demand function times x. And that's coming from price and demand and revenue and all that kind of stuff. Okay, so we need to find the function. So what we're going to need is we need the derivative of this function. I'm going to rewrite this as move this 3 up, make it to the minus 3. So I'll rewrite the function d of p equals 300 times p plus 2 to the third power. So that is just going to be easier to take the derivative. So the derivative function, derivative of the demand function, remember this tells us what price we sell, how many we will sell at a given price. So the 3 comes down, so I get 3 times 300 is 900 times p plus 2, this is all the out, so I'm taking the outside derivative first, chain rule. 3 minus 1 is 2, so it's now squared. Derivative of the inside is just going to be 1, right? Derivative of p, just 1. So we could put here, okay, times 1. That disappears. We don't need to write that, but I just want to show you chain rule, just in case we had something else in here, like a 3p, then the derivative would have been 3. We multiply by 3 again. Okay, don't forget the chain rule. So that's our derivative. That goes up here. We've got our function. It goes here. And again, I think we could just kind of, little grow. Careful here. This is a negative 3 because I moved it up. Oh my goodness. I'm glad I caught that. These are the types of things you have to catch. I'm glad I did midstream, because it would have caused a lot of problems. So a negative comes down, negative 3, so we get negative 900 here. And when you take negative 3 minus 1, you get negative 4, not negative 2. Or, yeah, wow, that would have been a big one. Okay, so I moved this up, that made it negative 3. Okay, that's why I try to go through these and just do it naturally, because what I found is when I make mistakes, I need to know how to catch them, and I'll naturally make mistakes if I just try to do it. If I practice too much, I don't make the mistakes, and then you know when you see something that's sort of been sanitized, you just don't get it. At least that was my experience. Okay, so let's come here. So this is our function. We're going to go e of p. So instead of using x, remember, just a different letter. We'll use p instead of x. So that's going to be equal to minus p, price, times the derivative function, which is here. So it's minus 900 p plus 2 to the minus 4. Okay, so that's that function. The demand function, the original, is 300 p plus 2 to the minus 3. Okay, now let's simplify. Negative and negative make a positive. Because the elasticity itself should be a positive number, it should be somewhere between 0 and 1, or 1 is unit elasticity. That's where we're going to get our maximum revenue. A number larger than 1 is elastic, meaning that the change in price has a tremendous effect on the demand. If it's below 1, then changing the price doesn't affect the demand that much. Okay, negative, negative, that's a positive. 900 divided by 300, that's going to be 300. There's this p, so let's do that. That's going to be 300 p in the top. The negatives are gone. And then what happens here? We've got a -4 and a -3. So remember, and there's this p plus 2. So we subtract exponents. -4. So what we're doing is we're taking, where do I want to write this? So -4 minus -3, right? So that's -4 plus 3. That gives us an exponent of -1 when we're done with these guys. So this kind of like, cancels out. We have a -1 exponent, so p plus 2 to the -1. Notice there's more up here, 4 is larger, so it's a -1 here, so it's going to move down. I'm gonna leave it up here, just so I think it'll make more sense. Now, yes, you could put that down here. I'll do it over here when we write it. I just want to see it's going to be this as our function, and we move that down to the bottom. So it's 300p over p plus 2 to the, well, not to the -1 anymore because it's been moved down, so it becomes a +1. So that's our elasticity of demand function. Find the elasticity given the price. So if we start with a price of $3, and then we got to determine whether it's elastic or not. So for this, E of 3, so let's just use this, is going to be 300 times 3, and they want it as an integer or fraction, so we won't make the mistake last time of turning it into a decimal when it doesn't want a decimal. This becomes 3 plus 2, and so we get 900. Really? Did I do all this right? Just doesn't seem right. 3 plus 2 is 3 plus 2 is 5. 5 goes into 900. That goes into 9 once. 4 left over. Goes into 48 times. So 180. 900 is, I think so. Let's just do that. It's just not feeling, something feels wrong, but I'll check it. I don't know what feels wrong, but just let you know, it's not feeling like, it's feeling like I did something wrong, but I know I've got the right formula. Negative's a positive. 900 divided by 300. See this? Check yourself. You guys probably saw this. You say, Little Crow, what are you doing? Don't you know 900 divided by 300 is not 300, it's 3. The zeros cross out. It's 3. Sorry, folks. There you go. See, you just sometimes, maybe it's better just go ahead and use that calculator. So we'll take these zeros out. A big difference. Not 180. It's just 9 over 5, which doesn't reduce. Okay. So I'm glad I catch these things, because I when your heart's telling you, I said that number's going to be way too big. That's what got me going. 900, it's 180. You don't. That's not a elasticity number. It should be closer to 1. But notice this is bigger than 1, so it is elastic. If we change the price, we'll actually increase our revenue. And it's telling us, really, we need to get that price lower to get the demand up, and we'll actually make more revenue. So the value for which the total revenue is a maximum. And what we're going to do is we take our elasticity function, 3p over p plus 2, and so let me scroll up a little bit. We're going to set that equal to 1. Go back to here. Just 3p over p plus 2 equals 1. And I just did it that way. Remember, that's 1 over 1. We can cross multiply, so we get 3p equals p plus 2. Or just multiply both sides by p plus 2. Subtract p from both sides. We get 2p equals 2. And then if we divide both sides by 2, we get that P equals 1. So at a price of 1, the elasticity function's equal to 1. It's cool. So don't charge $3, charge $1. You'll actually maximize your revenue. Of course, in business, what we're looking to is maximize profit. Usually maximize your revenue will help, but it depends on what our cost functions are too. So, but this is one way of looking at things, of setting a price. And you can get these demand functions based upon sales data. That's how they can do these things, changing the price over time, all that kind of stuff. So this is the theory. That's that. I hope that was helpful. Hope I caught everything. Again, I always check my answers afterwards, so if this video is posted, it means that the answers were checked and they're correct. If I check and they're not, you'll never see that video. I will not show you that one. So I got to catch my errors as I go. Thank you guys. Move on to the next one.